All right, guys, I'm going to walk through the car wash project here. It's a 5-page document, but if you're looking at it, there are some pictures, so it's not really like a fully 5 pages. I'm going to jump right into it and go right through the walkthrough topics. We're going to start with cleaning data and manipulating strings. I already started it here and already copied all of this at the top. I copied it right into here, so that way we could save a little bit of time. So the first thing I want to talk about is the dot upper and dot lower methods. We've already done this before, right? Imagine when we were like asking someone to type in, I'm going to go ahead and use an input function here, right? But let's say we just say like enter your username. Enter your username. Right? And then I'm going to store that input as username. The good thing about this project is this week, you don't have to use tk-enter. I'm just asking that you know how. I mean, that might be good news to some of you. You don't have to use tk-enter. You can just, it will be, I think, an easier project overall. But I just wanted to throw that out there in the beginning. So if I store this as username, right? Before, remember the way that we did it? We used to do, oh, well, what I want to do is I just want to take anything that they put and convert it to lowercase letters, right? And you use dot lower. We did that in the survey, I think, was an example of when we did that. And then if you were to print out the username, right, it would do this. This was the way we originally learned. So if I say enter your username and I say like Danza, oh, spelled it wrong. Well, see how it converted it all to lowercase? That was the first way I taught you how to do it because I thought it just made sense in order to present it like that. But you can actually limit lines of code. Now, you want to write your programs as concisely, and I guess the goal isn't to write beautiful code. The goal isn't to always, like sometimes you just want to write to make it work. Sometimes when I first am writing code, I'm just trying to make it work. And then I can go back and make changes and do things to it to clean it up and make it look nice, right? But in this example right here, I taught you dot lower already. Well, let's say I want to make this a little bit cleaner. I want to limit the lines of code. What I can do is I can just take this right here, dot lower, and just tack it on the end of this line right here and take this entire line out. And it will do the same exact thing. I need to start leaving my phone at home. I never bring it for that reason.
The sound is funny.
That's my Samsung Galaxy. Let me see if I can turn off the. I tried turning it off earlier. All right, now it should be on silent. Should. All right, so we're able to do the same exact thing by just tacking on dot lower at the end of this. So really, you enter your username, it then converts it to lowercase, and then stores it in the username. So instead of like adding an additional step, you can just throw it all into one step. So check this out. I'll write my full name, right? And it converts it all to lowercase. Now, the other way would work, right? And I taught you that way, so that way I feel like if I taught you originally this way, maybe some of you wouldn't understand, well, wait, we're doing more than one thing in one line of code. Yes, you can do more than one thing in one line of code, right? If I were to say dot lower and then dot upper right after it, it would convert all to lowercase and then back to uppercase. But if I just add dot upper, right, it's going to do the same thing it just did. So if I say like J Danza and press enter, it converts it all to uppercase. Like I mentioned before, the practical use of this would be if you're looking at a database, right? And you're storing your data and you want to store everything as lowercase or you want to store everything as uppercase. This is a way to do that. Okay? So it's a way of like cleaning data and make it look a little, even though you didn't know you were doing that earlier, that's what you're doing. So we've already talked about dot upper, dot lower. But then we have these things called islower and isupper, right? So I'm going to take away the dot upper. So we already talked about 1. Check that off. We're going to move to 2, which is islower and isupper. Basically, this is a way to ask a question. Is this uppercase? Or is this all lowercase? So I could say, let me print this out here. Instead of printing the username, I'm going to print, I'll say all lowercase, question mark. And then let's do this. Say all lowercase. And then I'll print another one. And I'll say all uppercase. Eventually we'll edit this a little bit more, but I'm just printing this out ahead of time. So let's say the user types in something and stored his username. And let's just say I ask the question, I'll just create a variable called L. And I'll say username dot is lower. And then I'll create a variable called like U for upper. So L for lower and U for upper. And I'll say username dot is upper. And what each of these functions does is upper really just asks, or is lower asks, are all letters in here lowercase? And this is asking, are all letters in here uppercase? So you don't have to write like an if or anything here. It just automatically gives you a true or false. So it's going to give you a true or false Boolean value. All right. So what I'm going to do here is I'm going to make this an F string, right? And I'm going to go ahead and put L for lowercase. It's going to give me a true or false. And I'm going to put U for lowercase. So let me walk through before I run this. We're going to take whatever the user entered and store it as username. I'm then creating 2 variables, one called L for like lowercase and U for uppercase, and saying, all right, I'm going to ask, did the user enter all lowercase letters? If so, then L should be true, and it will just show up true. Did they enter all uppercase letters? True or false? So let's run this. Let me show you how it works in action here. I'll say like JDanza. Are they all lowercase? True. Is it all uppercase? False. All right, let's what I'll do is, so that way it loops over and over and over again, and I can keep doing it without running the program over and over. I'll temporarily put this in a while true loop. So that way it just loops on forever and ever and ever and ever and ever, right? So while true, let's do this. So if I run it, enter your username, JDanza, all caps. Okay. Are they all lowercase? False. All they all uppercase? True. What if I did like JDanza123? You guys think that this will turn up true or false for all lowercase?
I think there will be an error.
So I got true because that's a good guess. I originally thought that when I was learning it, right? But it's saying are all letters in here lowercase. It's not saying are all characters lowercase. So is every letter in here lowercase? Answer is true. 1, 2, and 3 are not letters. They're numbers. So it's either one or the other. And if I say, I don't know, JDanza, upper and lower, right? And run it. Are they all lowercase? No. Are they all uppercase? No. It's a mix of both. Right? So there's a few more of these I'm going to tack on here. So we have isalpha. is 1. And I'm just going to, I'll call this Al, right? And I'll say username dot is alpha. And that's basically asking, are all characters in the alphabet? Remember, the alphabet is A to Z and then A to Z uppercase. So if I run this, right, I'll say print, and I'll create an F string here, and I'll say all in alphabet. And then I'll say Al. Because remember, that gives me a true or false. So let's run this. I'll say, I don't know. Enter. Were they all lowercase? Yes. Was it all uppercase? No. Are they all in the alphabet? Yes. What if I say like JD123? Are they all lowercase? Yes. All the letters are lowercase. Are they all uppercase? No. Are all of these letters in the alphabet, or all these characters in the alphabet? It's false because 1, 2, and 3 are not in the alphabet. Okay? What if I said like Mr. Danza? What didn't it like? Why are these not in the alphabet? What didn't it like?
The period and the space.
Didn't like the period and the space. What about this? What didn't it like in this?
Space.
Didn't like the space. Right? These are not all in the alphabet. So there's a few more. You know, there's a lot more, but we're just going to go through a few more. Is alpha. Then there's is alnum, right? And I'll call that AN for alphanumeric. And alphanumeric is alnum. And I'll say, are all characters alphanumeric? And what does alphanumeric mean? That means that it's either that it's A through Z, 0 through 9. So that's alphanumeric, meaning the alphabet plus all the numbers, the decimal numbers, right? So I could do the same thing here. I'll copy this. Whoops. Maybe I'll go through all of them first and then print them out. So I'll save some time. The next one is decimal, right? So I'll call that D, and I'll say username is decimal. Are all.
There's a space.
What's that?
There's a space in between decimal and the parentheses.
It may look like a space, but it's not.
That's weird.
Yeah, trying to catch me. It's like, yeah, that'd be a good call if I left the space there. Are all characters decimal? And we'll say like 0 through 9. So there's decimal, and then there's space. So I'll call it spa. Okay, and I'll say username dot is space. All of these return true or false. I'll say are all spaces. You guys know what spaces are. And then I'll do I'll do title. I'll just call it T. Username, and I'll say is title. And then I'll say, is it title case? And title case is like, I don't know, right? Or, I don't know, whatever. That's an example, right? I'll just say like, it's a title of something. I could say, or computer science principles. So the example of title case would be that you have a capital letter, letters, lowercase letters, space, capital letter, lowercase letters, space. In our example that we used in the Google Sheet, when I was trying to look at names before I started this video, that would be an example of title case, right? All right, so these are some examples here. If I go through and I'm going to go through and copy some of this, right? And then give you examples. So one, how many did I do? 4, 5, 6, 7. So 5, 6, 7. Not in the alphabet is alphanumeric, is all decimal, all spaces. Let's say title case. And these aren't AL. I call this AN. I call this D. I call this SPA. T. All right. I'm going to run it, and we're going to try some examples out and see what we get. So enter your username. I don't know, JDanza, right? Are they all lowercase? Yes. Are they all uppercase? No. Are they all in the alphabet? Yes. Are they all alphanumeric? Are they letters and numbers? Yes. Are they all decimal? No. Are they all spaces? No. Are they all title case? No. Let's do, I don't know, Danza 1, 2, 3, right? They're all the letters are lowercase. They're all alphanumeric. They're not all decimal numbers. They're not all spaces. They're not title case. What about 1, 2, 3, 1, 2? I don't know. It is all alphanumeric. They are all decimal numbers, but all the others are false. What if I just add a bunch of spaces here, right? Like you're trying to submit a form or something and it's required and you don't want to actually submit anything. And you guys ever done that? I've done that. And you click space a bunch and then press enter, submit, and then it comes back and says you must enter something. Well, they checked to see if they were all spaces. So it's saying all spaces, true. If I say like computer science principles, are they all lowercase? No. Are they all uppercase? No. Are they all in the alphabet? False, because there are spaces. Are they all alphanumeric? The spaces get you. Decimal. Is it in title case? Yes, it is true. It's in title case. So these are just ways to look at data as they're coming in, find out information about it, and then like how do we like clean that data up? Well, we can convert it all to lowercase. We can convert it all to uppercase. Those are two ways. Or we could deny it. We could say something like, if L is equal to true, or if everything's not all lowercase, right? Then say, hey, you try re-entering your password. Right? That's one example of when we could actually use it in a practical sense. Okay, so like I said, the reason I had that while true loop was just so it kept on running over and over. You didn't need to do that, but the in and not in, right? So I can make something else. I'll just add this example because we've already kind of dove into it. I'll say, let's say you have to have, I'll just add to the end. How about that? I'll say like if there is I'll use a random character. If there is an exclamation point in your username, print you cannot have this symbol in your username. else print your username looks good. Say the only requirement in your username was that it doesn't have the exclamation point, exclamation, question mark, exclamation point, question, exclamation mark, exclamation point. Sorry, I always mix them up. All right, so let's say you cannot have the symbol. So you can use the in operator to check if something's in there. Which project did we use the in and not in operators? You're checking if a letter was in something. Yes.
Not Wheel of Fortune, but like guessing, like where you guess like the letters.
Which one did we guess the letter? Wheel of Fortune? Yeah, Wheel of Fortune. Yeah. That's the one I thought of. That it spun around, the wheel spun, and then you had to guess a letter, and then you wrote, if this letter was in the secret word, then do something. So we've already learned in and not in operators, right? But you can use it in this example right here, right? I'll say Danza with exclamation point, right? It says, gives me all these stats. It says it is in title case. Interesting. You cannot have this symbol in your username because I add an exclamation point. And if I just enter something random, right? And said your username looks good. So that's when you would use in as an example, right? Let me see what else we got here. All right, number 5, it says the starts with and ends with. So maybe I'll add something up here. I'll say, maybe I'll add more conditions down here. I'll say like if username, let's say I'll write a comment here and I'll say this is where I'm evaluating username, see if it, I guess, fits the rules or if it is okay by the rules. I'm sure there's better English to that, but I'm just having a blank, right? So I can say something like, if the username dot starts with, and then, I don't know, let's say it starts with a D. I could say print your username cannot start with a D. I'm not sure why, right? I don't give a reason why, but let's say you don't want username to start with a D. Or
Every person with the name starting with a D just got outed.
all the D names. Sorry guys. Let's say I just have something against people with D names. And then everyone else, and I'll say your name doesn't start with a D. You must be cool, right? So if I go through and run this, right, it's going to see, does it start with a D? And my last name starts with a D, so I'm not cool, right? So if I say like Danza, right, says your username cannot start with a D. But it said the username looks good there, right? I'll say the username, your username doesn't have an exclamation. Oh wow, that's really spelled wrong. Exclamation point. So if I run it again, all right, I can say something like enter your username. I'll say Your name doesn't start with a D, you must be cool, right? Your username. So your username doesn't have an exclamation point. Good. So you should be good to go after that. It can also, with starts with, you can use starts with or ends with, right? So starts with, or you can even use ends with, and it does the same exact thing, only ends with the bottom. Or let's say it can't start, let's say starts with, it can't have danza, right? Like your username cannot start with danza, right? So if I run it, enter username, danza123. I've been banned from this website. I'm not sure why. It says your username cannot start with danza. That's sad that they banned me from it, but you can use starts with, or even you can even say if or username dot ends with. You can't sneak any danza in there, right? That's how you would ban me from the site there, right? You can't. We don't speak that name. So that starts with, ends with. Just take a deep breath. There's a lot of information so far. Got all that done. We need to do this. Well, let me show you this. So, whoops. Anything beyond this point in 10, 11, 12, 13, these are not required for the project. But for the project, we just did all this. We're about to do this, so take a deep breath. We're going to do the join, the split, moving white space. I feel like I started to lose people around this point before. So, and then we're going to do try, accept, and then load and dump using the pickle method. This down here allows me to store things through serialization, which I'm not going to talk much about serialization, but I'll show you how to store things. All right, so let's do this. Let's put a block string around this. Okay. And let's just say, all right, there you go. That was a cool little mini project we did. Don't really see the practical application of that exact project, but hopefully there are things that you see the use in already. All right, so the next thing we're going to do is we're going to talk about the join method. The join method allows you to take a list and then put them together into a string. So let me show you this. So if I take, I don't know, let's say classes. Oh, I want to stay away from using the word class. Don't want to, that's for object oriented. We're not going to talk about object oriented programming this year. If you guys take computer science CSA, APCSA, then you guys learn all about object oriented programming. That's not a requirement in this class. It would be helpful, but we're not going to talk about it in this class. But let's say we take course, and I'll say courses. Let's say all the classes you're going to sign up for next year, right? So, religion class, and then say English, and we'll say calculus, because all you guys are taking calculus next year, and let's say AP Computer Science A, and let's say cybersecurity. Some guys are like, I'm not taking that class. What else? Lunch. Hopefully lunch comes back. That'd be cool. Hopefully lunch comes back. 1, 2, 3, 4, 5, 6. What other classes are there? You got some kind of science, right? So you'll take physics. And then I guess you gotta take history, right? So I say like government. I don't even know. This might be some of your schedule next year. And you're like, hey, that's my schedule, right? Let's say those are all the courses. And let's say someone asks you and says, like, what classes are you taking next year? You can do this, right? You can say, all right, I'm going to use a join method, and I'm going to join everything. I guess maybe I'll I'll assign something. So I'll say C for classes, all my classes I'm taking. And I'm going to join all of my classes together by a comma and a space. Okay, and I'll say join, and then I'm going to go ahead and just dump my courses in there. So I'm going to join them all with a comma and a space. So if I print something out and I say, like, I'll use an F string, right? And I'll say, next year, I will be taking, and then I'll just say C. If I run it, watch this. Next year, I will be taking religion, English, calculus, AP Computer Science A, cybersecurity, lunch, physics, and government, right? And I combine it with a comma, right? But let's say I want to combine it with just like slashes. I don't know why, right? If I run it, watch this. Next year, I will be taking religion, English, calculus, AP Computer Science A, cybersecurity, lunch, physics, government. Or if you wanted to combine it with and, right? I'll add a space before and after, right? So religion and English and it goes through the entire list and it iterates and loops through the list for you, right? So next year I will be taking religion and English and calculus, and your English teacher would hate this sentence, right? What's up?
Is there a way to put like a comma for everyone and like and the last one?
Yes, there is. We can talk about it after class. All right. So I just don't want to. There's so many other things, and then I'm gonna get I'm just trying to squeeze it all in here. So this would be a way to loop through and add this to all the items on your list. All right. Now the opposite of that, right? Let's say I'll put this in a block string, right? Let's say I want to take, let's say I want to take a variable, I'll just call it X, right? And in there, I'll just type like, this is a sentence. I hope I spelled it right. Say like, this is another sentence. And then here is a third. Let's say I want to split this up. And let's say I'll create another variable. Maybe I'll call it Y. And I'll say X dot split. And I want to split it by, let's just use the split and just use it as is right here. And then I'll print out Y. So I'm taking the sentence, or this string, this is a sentence, this is another sentence, here's a third, and I'm going to split it up just by spaces. Watch this. If I run it, I split up into a list. This is a sentence. This is another sentence. If I wanted to split it up every single time that there's a period, I would actually type in that period there. Now watch this. I should have 3 items in my list now. Well, I actually have a 4th one here that's sitting there because it says this is a sentence, this is another sentence, here's a third. So maybe I'll do something like this. I'll say period space. This is a sentence, this is another sentence, here's a third. All right, so I'm able to take strings and split them up into lists by using the split method. Let's say you're able to pull information or pull data from a website, which we'll talk about later. We'll talk about web scraping, not today. But let's say you're pulling data from a website and you would like to pull, you'd like to split it up into a list so you can eventually store that information. You can do that based or using the split method. I've used it a lot before. So that's one example. Another thing you can do is you can remove white space using the strip method as well. And I'm going to go ahead and just put a block string around this. So let's say a user enters in, I'll just say, I'll just call this X, right? And I'll use input function and I'll say type anything. And what I can do is I can remove all of the white space by using the dot strip method. And I could have, remember how we did the dot lower and I put that down there before, but then I added it up here to take away a line of code? I can do that here and I'll print it out. So strip removes all white space. And I'll show you what I mean here. So let's say they go to enter something and they accidentally add some spaces ahead and they type in their username. It removes that white space for me and takes away all the spaces that I typed. Okay, so strip takes all the white space off. If you only want to remove white space from the right side of what they type, use rstrip. If you only want to remove it from the left side, use lstrip. But if you want to remove any white space, another good example would be, let's say you just finished typing your username, you accidentally click space. You can save the user the time by just saying, oh, they didn't mean to add that space, and remove that white space off the end. And just, if you look at it, see how if I click here, there's no white space afterwards, but here there's that extra space. So that could be used in a login. But really, if a user isn't typing in the right username, they shouldn't, like, you should send them an error. But if you're like, oh, they just messed up a space, then you can do that. All right. You can also do more than just strip white space. You can strip letters. So let's say I want to strip A. It can't end or begin with the letter A. So if I say like Mr. Danza, right? It takes off the A at the end. If I were to type in, hey, you know what? Strip anything that ends in Danza, right? We don't like the Danza example. I'll say like Mr. Danza, and it just completely strips off Danza. You could use this for an example I think of, maybe even like a profanity filter, right? Remove these words, strip any words that end in this or contain this, which that's containing something is entirely different. You can say in, right? We talked about the using in to see if something's in there. So you could use that as even like a profanity filter, for example. But stripping that off the end of a word, that's one way to help clean up some sort of user input. All right, so far so good. I don't feel like this lesson is going as maybe, I wouldn't say poorly, but before it just felt like a lot of information and I was kind of squeezing it in. I always feel like the last period of the day is shorter than all the other periods, right? So I'm going to go ahead here and keep going through. All right, we are going to use something called the try and except. All right, so let's say you're ever about to run code and you're not sure if it's going to run, or even a section of your code, and you want to try something first. Some of you guys have been using this for a long time. Some of you guys have been writing this in your code consistently, and I appreciate it, but we're just now actually getting to it in this class. You can use something called the try and catch. Let's say I want to try, let's say I just have a number, let's say X, and I'll assign it 9, right? And let's say I want to try to divide that number, whatever that number is, which is 9. Let's say I want to try and divide 9 by 0. You can't divide anything by 0. Normally you get your program will crash, right? But to prevent your program from crashing, you can write an except. Basically like saying like, hey, look, like this is another way of writing almost like an if else. If this happens, then fine, let it run. Else, if it doesn't happen the way that you expected it to, then do this. So imagine this kind of like an if else. We're like, hey, try this. If it doesn't work, then print out, say like there was an error. If I run this, it says there was an error. But if I change this to just say, I don't know, let's just print X. I run it. It prints out 9. So it tries this. If there's not an error, if there's no problem with your code, then it runs it. If there is an error, then you can make it do whatever you want. We're going to use this in the next example. And the first time I went through and taught this, I didn't realize I could have like led in like this. So this might be a little easier. But you're going to be using this in this very next example. Let me show you why. Okay, we're going to talk about pickle, the pickle module, right? All you have to do is type import pickle, the same way you type import random, import time. Those are some modules. Import tkinter, or from tkinter, import all. Right? But you're importing something. It's called pickle. Pickle is used to store things that you want to use later. So some of you, actually in your project for your create task, wanted to actually store something so that way you could close out of your program and then come back to it later. There were many different solutions. In the next 6 weeks, we're going to be talking about 6 ways of storing things. Today, we're talking about a module called pickle. Next week, we're going to be talking about shelve. The week after that, we'll talk about text files. Then we'll talk about CSV files, comma separated values. And then the last week, we'll talk about JSON files. Some of you guys might be familiar with JSON files as well. All right, so we'll be spending some time going through this. But what I want you to do is, I want you to imagine that a pickle file just stores information, stores data. So if you want to access something later on, like I wanted to store it and then close the program and then re-access it, you could use pickle. And it uses something called serialization. You don't have to know what that is right now. Just know that we're using it in order to...
An acronym?
What's that?
Is pickle an acronym?
No, they just want to imagine like you're pickling something and using it later. You know what pickling is? Like you put in vinegar or whatever. I don't even know how to. What is it? Vinegar? Yes.
Is there a way to like, instead of saying like import pickle or like import TK, is there a way to just like make it where it's like say import like A or something, and it imports that module and rename the module?
Yeah, you can say as. So like import pickle as like P. Yeah, you could do that.
I have no idea what how some of these modules are named. Like turtle, I don't know how that has to do with graphics. And tkinter, what does TK mean? And also inter?
Inter is for interface, and TK is like the class that exists. I'm not 100% sure. Right, I could probably find it out in 2 seconds if I Googled it. But TK is the class that you would use. The set of like the toolkit is called the TK toolkit. I'm not sure what the T and the K stand for. But inter is like interface, like user interface.
Yeah, I don't mean to get you off track. I just find it funny that like this is probably the reason why everyone looks at code when they're not familiar with it and then gets instantly confused.
Yeah, exactly.
A random word like turtle and pickle.
Yeah, well, there's also a really good web scraping module called Beautiful Soup. So another random name.
That's even more random.
So This is import pickle. So imagine that you're taking something, you're putting it in a pickle jar, right, and putting it aside, and you're going to use it later, right? I guess, I don't know. They just try and think of funny things to name. So import pickle. Now, let's say I come up, I want to store my favorite number. And let's say I just have really bad memory, which at times I do have a bad memory. And I'll just call like my favorite. Well, here's what I'll do. I'll load it, right? I'm going to use the pickle module, and I'm going to say favorite number is going to be equal to, I'm going to go using the pickle module, I'm going to load my favorite number from the last time, right? Whenever the last time was that I used this, and I'm going to open a file, and I'll call it like favnum. Let's just say like favnum 2021. This is my favorite number, 2021. And you know how like you can save things as like a .txt or a dot, for Python it's py, right? For pickle you can use .p. Okay? And you're going to read whatever's inside this pickle file, you're going to read it. And the way you signify you're going to read it is you type in RB for read binary. You guys all know what binary is, right? So you're going to read the binary. So you don't have to memorize this. A lot of the programming stuff that you use, even in advanced Python stuff or advanced programming, you don't have to memorize it. You just have to know how to use it, right? So I guess I need another parenthesis to close that, right? So let me just walk through. I should probably spell pickle, right? So you're going to use the pickle module. You're going to load from the computer, right? You're going to open up the file. For this, I just called it favnum 2021, my favorite number of 2021. And then I'm going to read it. And I'm going to store that as a favorite number. So let's say I typed in a favorite number before, I'm going to have to access it again. Now, the way that I'm going to ask a question, and I'll say favorite number, and I'll say input. I'll say like, what is your new favorite number? Let's say I only open up this program every single time that I have a new favorite number. And I'm going to store it now as a favorite number. How do I save it so if I log back in, I can use it again? Well, what I would do is, instead of the .load, I'm just going to dump it. Pickle.dump, right? And you're going to, what do you want to dump in there? Well, you're going to dump in your favorite number. Okay? And where do you want to put it? I'm going to open it back up. That same favnum 2021. And what do I want to do to it? I want to write binary. Okay, so RB, I'll write a comment. RB is for read binary. WB is for to write binary. Okay, and you're done. So, whoops, I got to add one more close parenthesis on here. All right, so if I run this, I'm going to get an error. Watch this. It says there is no such file as favnum 2021. The reason is because there's no favorite number stored in there. I've never entered a favorite number before. I'm loading a favorite number that doesn't exist yet. So what I can do is I can use try. Try it. If it works, great. But if not, I almost write catch there. I almost wrote catch accidentally. Except what you can do is, if it doesn't load, if it doesn't work, if I get this error right here, I can write something called an exception and say, all right, if there isn't a favorite number, I'm going to basically default it to 0. So if there isn't already a fave num, default to 0. So this should take away this error. So I ran this originally and didn't have the try and accept, and it says, hey, look, I tried loading this and reading the binary, and there's no such file. It's because we haven't stored any favorite number in there yet. So we'll try to open it up. If it doesn't open, then we'll just say, all right, your favorite number is going to be 0. But then we'll ask you what is your new favorite number and then store it. All right, so we'll run it. What is your new favorite number? And it worked, 23. And it's done, right? All right, I stored my favorite number. I can close out of everything, right? Wait a couple weeks, and I wake up one morning and say, hey, you know what? 23 is no longer my favorite number. I say 23 because my dad played professional baseball, and he was number 23. My uncle played professional baseball, and he was 23. My cousin played at Stanford University, played football there, and he was number 23, and then eventually turned to number 3. So for a long time, and Michael Jordan was my favorite player. So for a long time, I really liked 23. I wore 23 here at Spalding. I got to college, and they didn't have number 23. So I had to pick a new number, and I ended up wearing a bunch of different numbers. But let's say I wake up and I say 23 is no longer my favorite number. Me and my dad got in a fight, and my new favorite number is 9. So let's say I go back, right? I'm like, all right, let me go to my favorite num program. Let me open it up. What did I even name that file? Was it this one? Yeah. So, right? So, all right, I need to change this. Let's run it again. And if I run it, remember, weeks could have passed. If I run it, oh, I need to print out what my favorite number was. Sorry, print. And I'll just say your old favorite number was, and then I need to put in your favorite number. Sorry, I forgot that line of code there. Yeah, I gotta put an F in front. All right, so let's run it. Your old favorite number was 23. So I'm like, all right, you know what? I don't want to change my favorite number. Let's not do that today. But then I wake up a couple days later and I'm like, yeah, you know what? I really, it's time to change that favorite number. Let's go ahead and do that. So I'll go in, I'll find my file. Right? Let's run it. Let's change my favorite number to 9. Your old favorite number was 23. It remembered. It pickled that information. It took it, you opened the pickle jar, you put it in there, and put it aside. And then later, it called it. It used the, if you look at it, it used the load method to load it, open up the pickle jar. The load is like bringing the pickle jar in front of you. The open is to open the top of it, and then you say, what do you want to do with it? I want to read it, RB, right? So then I have, at the very end, once I've messed around with it and I want to change it, I'm going to have to dump it back in there. So I take whatever, I'm putting it in the pickle jar, right? I'm opening the pickle jar, I'm writing binary, I'm putting it in there, closing it, and then putting it aside. That's the very end with the dump method, right? So what is your new favorite number? 9, right? And I can close out, right? So let's say a couple more days pass and I'm like, nah, you know what? Like 23 is a family number. I need to keep that same favorite number. This obviously makes no sense. So, you know what? I want to change my favorite number back to 23. If I run it, it says your old favorite number is 9. What's your new favorite number? And I'll say, all right, it's 23. Right? So even if I close out of it, it still shows up, right? Your old favorite number is 23. What's your new favorite number, right? I could even add something in there that's like isdecimal, right? And then if it doesn't, like if isdecimal is false, then have it loop through and do it again. That's one way of using the isdecimal.
So by using this, you could run the program, enter a value, and then you could close the program, and then it would update the value based on what you did last time.
Exactly, like a high score. Save a high score and come back. This was your high score.
Yeah, that could be really useful for video game making.
We're going to be, over the next 6 weeks, we're going to be talking about 6 different ways to store things. Today's way was pickling things. Next week, we're going to use something called shelve. Basically, the way is like putting it on a shelf, right?
Does pickle have anything to do with putting a value into a file that it uses as a directory? I don't actually know how directories work, so I don't know what I'm talking about.
No, you're fine. Yeah, so we're putting this pickle file, we're putting it in a directory within this program, right? So we're able to look into, if I'm able to look through the directories, you could locate this, okay? And we're writing it as binary. There are ways to write it. I think there's ways to write it just as W and just as R instead of write binary and read binary. But this is the way that I've used for a while. So anyway, that was everything, right? That was everything I wanted to show you. Hopefully that wasn't painful going through. Hopefully there's something that you learned in there. I feel like it didn't work this well out the first time around, but I think one of the big concepts, or one of the big things to know is you don't have to use try and accept, and you don't have to use pickle in your project. So now that we've walked through all these topics, what I want to do is I want to walk through the rest of this project so that way you understand what's going on. Okay, so we did all this. We split it up and we're able to walk through each of the concepts. So last week we talked about binary numbers, and we're going to continue talking about binary numbers right now. It says the way a computer represents data internally is different from the way data is interpreted and displayed for the user. Programs are used to translate data into representation more easily understood by people. Very true. We have a user interface. We like being able to use a graphical user interface in order to interact with something. So explain how data can be represented using bits. And it says analog data, we're about to compare analog data to digital data. Analog data has values that change smoothly rather than in discrete intervals over time. So this is an example of analog data, right? Analog are these waves that are sent up and down, and it's more smooth of a flow, right? So analog data, some examples include pitch and volume of music, colors of a painting, or position of a sprinter during a race. So these are constantly flowing, and they may be they are going to be in a smooth interval, but it's not going to be a discrete, exact, more choppy interval. It's going to be very smooth. The use of digital data to approximate real-world analog data is an example of abstraction. So we take analog data, right, like audio or video or different statistics that can be measured smoothly. And we do this thing called sampling in order to break this down. And sampling is used in order to take analog data and convert it to digital data. So we can send it over the internet. We can send it between computers. We can store it. So as you can see, it says, this is what data looks like when it's sampled at 10 points, right? It looks a lot more like this original wave that's sent out. That's at 10 points. At 6 points, see it's a little choppier. And sampled at 2 points, it's just, it doesn't even look like the original waveform. So the more points it's sampled at, the more clear, the more concise, and the better it ends up looking when you are actually converted to digital data. And that process is called sampling. Okay, so analog data can be closely approximated digitally using a sampling technique, which means measuring values of the analog signal at regular intervals called samples, right? Just sample 1, sample 2, sample 3, sample 4. The samples are measured to figure out the exact bits required to store each sample. So we're taking something and we're trying to store it and change it into a digital format. You guys ever see like old movies that say they've been digitally remastered, right? So we try and take this original waveform and we convert it to a digital format. And the process of that is called sampling. Okay, data compression. The way a computer represents data, the way a computer represents data internally is different from the way the data is interpreted and displayed for the user. Programs are used to translate data into a representation more easily understood by people. That's the same exact line as what we had up there. Compare data compression algorithms to determine which is best in a particular context. It says data compression can reduce the size, the number of bits or of transmitted or stored data. So you take any sort of data and you compress it in order to, like, let's say I wanted to send an email with a really large attachment. I could compress that data so that way I could send it maybe in a zip file. I zip the file up so that way it's compressed, send it over, and then you can unzip the file once you receive it. But you can reduce the size through compression. And we're going to dive deeper into this in a few minutes, but you'll understand it a little bit more, especially in the activity that's at the very end. Fewer bits does not necessarily mean less information. It's not true. The amount of size reduction from compression depends on both the amount of redundancy, means things we can repeat, in the original data representation and the compression algorithm applied. So what are we doing to actually compress this data? Well, there's two types of data compression that we're going to talk about: lossless data compression and lossy data compression. And each have their uses and reasons why you would use lossless or lossy data compression. Easy way of noticing the difference between the two: lossless means that when you compress the data, there is nothing lost. There's no data lost in the compression of it, right? Lossy data means that things can, even though it reduces the number of bits and and does actually compress the file, it actually loses something in the process of it. It might lose quality. So there are reasons to use lossless data compression and reasons to use lossy data compression. Lossless means nothing gets lost, and lossy means some things do get lost. So lossless data compression algorithms can usually reduce the number of bits stored or transmitted while guaranteeing complete reconstruction. Okay, not partial reconstruction once it's completed, like once you've actually opened the file back up after it's been compressed, right? It will allow complete reconstruction and it guarantees it. Okay, so let me do that. It guarantees complete reconstruction of the original data. Lossy data compression algorithms can significantly reduce the number of bits stored or transmitted, but only allow reconstruction of an approximation. Okay, so when you're reconstructing it, it's not going to necessarily be the best quality. Well, why would you compress something with knowledge that it's going to lose some sort of quality? Why would I do that? Well, we're going to talk about that in a second. Lossy data compression algorithms can usually reduce the number of bits stored or transmitted more than lossless compression algorithms. So you're able to send over a smaller file using lossy data compression. Okay, in situations when quality or ability to reconstruct the original is the most important, then use lossless compression. Okay, in situations when just minimizing the data and just being able to send it over, or the transmission time, like you really need to send this over quickly, if that's the most important side, then lossy compression might be the best. Okay, so lossless would be if you really care about the quality of, let me use like an image, for example. Let's say you contract me to design a logo for you. I want to make sure when I send that over to you, it is of the highest quality. Now, at the same time, when would I use lossy compression? Let's say you're streaming video, right? Let's say you're on YouTube or you're on Netflix and you're watching something. A small decrease in quality is not always noticed when you're streaming something. And I believe, to me, I would rather be watching a video consistently with a little almost unnoticeable quality loss. I'd rather there be just a little quality loss and consistent video than great quality and buffer every like couple seconds, right? Lossy compression is used a lot of times during video streaming just because if there is some sort of interruption, they're not trying to push this big file to you. They're not trying to push a high, super quality file to you, that they will reduce the quality to make sure it gets through. Okay, so sometimes you might notice that if you're watching a video or streaming something and the quality decreases slightly, right? They're probably using lossy compression. So as you see, the data size or transmission time is most important in those cases, rather than it being just you don't like instead of it being guaranteeing the highest quality. Now, it'd be great to have something that guarantees the highest quality and then also allows a very quick transmission time, but that's not always possible or not always the case. All right, so it says programs can be used to process data, which allows users to discover information and create new knowledge. Now, this is a lot of what we already have talked about in the project. I guess the walkthroughs that we did, all the Python stuff we did. We talked about information. We talked about data. We take data and we want to convert data to information. Information is the collection of facts and patterns extracted from data. Data provides opportunities for identifying trends, making connections, and addressing problems. Digitally processed data may show correlation, so there may be some sort of relationship between the variables. A correlation found in data does not necessarily indicate that a causal relationship exists, which means that just because you're able to find some sort of pattern in data, that does not mean that there is some cause behind, I guess if you're looking at maybe like, let's say like stock market data. If you're looking at stock market data, you can't always predict 100% of the time what's going to happen, no matter how much you study that data. Okay, so there's not always a exact reason exact reason that you can identify from data. Often a single source does not contain the data needed to draw a conclusion, right? If you only ask one person what they think about something, that might not always be the best way of collecting data, right? Even if you're just interviewing a professional, someone that has a lot of experience in the field, the more data you collect from multiple sources allows you to draw a better conclusion. It may be necessary to combine data from a variety of sources to formulate a conclusion. All right, it says describe what information can be extracted from metadata. Metadata is data about data. Okay. For example, the piece of data may be an image, while the metadata may include the date the image was taken or the file size of the picture. Changes and deletions made to metadata do not change the primary data, which means that if you're like changing the information about even the file name, that doesn't actually change the data. Metadata is used for finding, organizing, and managing information, right? I like using very specific file names and even dates to organize my data. If I'm looking at even programs that I'm writing throughout the day or examples when I'm teaching, I try to put an exact time and date of when I worked on it so I can always go back and find it. Okay. So it says metadata can increase the effective use of data or data sets by providing additional information. Metadata allows data to be structured and organized. All right, so identify the challenges associated with processing data. The ability to process data depends on the capabilities of the users and their tools. Okay, if you get all this data and you don't know how to process it, right, then that's not necessarily going to help you. Sometimes you might have to learn how to process that data or how to convert that data into useful information. Data sets pose challenges regardless of size, such as the need to clean data, incomplete data, invalid data, and the need to combine data sources. Depending on how the data was collected, it may not be uniform. It may not be consistent. It may not be clean. You may be collecting information from a form and a user type in their name in all caps, and then another user type in their name in all lowercase, and another one using title case. So it's not necessarily always going to be uniform. For example, if users enter data into an open field, the way they choose to abbreviate, spell, or capitalize something may vary from user to user. And if you're looking at a database full of all this data and it's not uniform, sometimes that can be a problem. Cleaning data is a process that makes the data uniform without changing its meaning. It's important to know that it does not change its meaning. Okay, I'll highlight that. Because if you're changing the meaning of collected data, then that's very misleading. Replacing all equivalent abbreviations, spellings, and capitalizations with the same word. Problems of bias are often created by the type or source of data being collected. Bias is not eliminated by simply collecting more data. We don't want bias in our data collection. We want to eliminate bias as much as possible. And those of you who have taken statistics or taken any sort of data collection course know that to be true. The size, I guess even in science classes, the size of a data set affects the amount of information that can be extracted from it. Large data sets are difficult to process using a single computer and may require parallel systems. Scalability of systems is an important consideration when working with data sets, as the computational capacity of a system, so what a computer can actually do, affects how data sets can be processed and stored. Okay. So moving on to the project, the first step is to create a Google Doc and to name it Car Wash Project and then your name. It says, watch this video. This video is a video on digital compression. It's 5 minutes long, talks about compression a little bit further. It says, for hands-on experience with text compression, complete this text compression activity. It takes me to this activity from code.org. And if I click on it, that's the video that it wants you to originally watch. And I get here, and it says, look for patterns or repeated words or phrases in the text. It wants me to see if I can compress this. So what I do is I create a dictionary. And I look for something that has been repeated over and over. And one of the things that I see that's repeated was, I was lost. And if I just backspace it so you can see it, right? I was lost, I was lost, I was lost. So I'm going to say I was lost. And if you look down here, it says by creating this dictionary and replacing it, this repeated, it's kind of like almost writing a function, right? And by replacing this, I've been able to compress this down 10%. All right, so I don't know, maybe I see I didn't know, I didn't know, I didn't know. So I'll say I didn't know. And then maybe also I see some other didn't knows. So I'll say like didn't know. Another one, I see I'm repeated twice. So maybe I do I'm. Anything else that I can compress here? And I'm just going through and looking through this. Maybe T-I-I-T was or and. Yeah, I guess there are some ands repeated. Wonder if that will work with caps. Yeah. So I can take and. I've already compressed this 32%. I'm not saying this is the most efficient way, but try and see what the highest percent compression that you can get on this is. And there's a bunch of different songs or different things to try and compress. This is a song by Aloe Black. A few of these are by Aloe Black, right? This is another one, right? And I can remove this dictionary. The Man. So pick a few of these and try and compress it. And this is how you would practice data compression. Okay, so it says choose 3 different text examples to compress. So choose 3 of these examples and see how high of a compression you can get. You don't need to have 100% compression, but just see what the highest number is you can get to. Take a screenshot of each of the 3 compressions and paste in your Google Doc. Now, everything down here, this is basically what we've already done. I basically wrote your project for you, minus the actual accepting the user input, minus the actually choosing which of these I want to do. And that's as simple as writing an if, else condition. So it says, imagine that your friend named Data is riding in a car and pulls up to Mr. Dan's car wash right next door to my PB&J food truck. I offer 4 different options at my car wash. You can convert data to all lowercase, all uppercase, split a string into a list, or remove white space. During the car wash, we also perform 10 diagnostic tests on your car and return the results upon completion. Okay, so what we want to do is we want to program. We want to write a program, and you can write it in REPL. You can write it in any code editor you want. You don't have to use tk-enter. You don't have to. You can do whatever you want, as long as it does these things. It needs to accept some sort of user input. So the user has to type something. You ask the user to enter some data. Then you're going to give them the option. Do you want to convert this to all lowercase, all upper? You ask them that question. One of these 4 things. The user decides, and then you actually output the cleaned data. We've talked how to do all of these earlier in the video. says return diagnostic feedback about the raw data, the raw data they originally entered. So you're going to check this raw data, whatever that the user types in here. Okay, so I'll say like raw data. And you're going to perform these 10 questions like, are they all lowercase? Are they all uppercase? Are they all alphabetical letters? We already did all of this, and I showed you how to do this. And then if you want to stop there, you're done. You can optionally use pickle. You can optionally use try and accept. And if you want to try TK enter, you can, but the pickle module does not always work well with TK enter. All right. I always say be creative. I always say you're encouraged to add on if you want to add more things. Take screenshots of your code in the code editor and your code's output. Do I need to use TK enter in my project? No. You don't, but you can if you like. And that's it. So, like I did before, right? And I'll pull this back up here. I'll show you what I did. This is just, these are all the block strings that we created earlier. And this was the meat of it, right? The first bit that we did. So you don't have to have a while true, but if you're asking 10 diagnostic questions, right? Here's already 1, 2, 3, 4, 5, 6, 7, right? And I showed you how to do the others as well. Okay, and here's 2 other things. So 8, 9 right there. So what you're doing is, it's very similar to this program. Follow the steps. Determine the way that you want to actually clean your data, and go from there. All right. So what I'll do is I'll pull this up so you can see some of this. Right? If you have any questions, please let me know. Hopefully this was helpful, and good luck on your project.